Okay, today we're going to look at solving vector questions that have two vectors in two dimensions, so both of them are going at angles. So that makes things a little more complicated, but what we have to do is we just have to break it down into a couple of steps where we do exactly what we did before. So we're going to first of all figure out what the vector components are, and then we're going to combine those and then figure out what the resultant would be. So the best way to show this is just to start with an example, so let's do that. So let's suppose our question is, so a person walks 15 meters at, so let's suppose we want to add 15 meters at east 30 degrees north, and then let's say they're going to go 10 meters after that at north 20 degrees west. Okay, so the question is, what is the resultant, what is our final displacement and direction? So for all these questions you want to find the length of the vector plus the direction. Okay, so our first thing is let's sketch out this situation. So let's suppose we started at the bottom here, so we're going to go at 30 degrees. Okay, so we know it's going to be 30 degrees from east to north, and this was 15. And then afterwards, the second vector, we're going to go from head to tail. So we're going to start the second one, and it's going to go something like that, right, where this is 20 degrees, and that one's going to go 10. So the question then is, what is the resultant? So our resultant would be from start to finish. Okay, so for us to try to do this with trigonometry, it's a little bit difficult because we don't know all the angles, we don't know whether it's a right angle triangle or not. So the best bet is first step is to figure out the components. So if we look at just that first vector, the 15, the first thing you want to do is figure out the vertical and horizontal components of that vector by itself. Okay, so we know it's 30 degrees, we know it's 15, so we can easily solve for each of those. So our vertical side, because the y is the opposite, so you'd have sine of 30 equals opposite over 15, and we can do that on our calculator. So just go sine 30 times 15, so that'll give us 7.5. Okay, so we know that that side is 7.5. And then we want to do the same thing for the bottom, but the bottom this time is adjacent, so we'd have cosine of 30 equals x over 15. So do that one on your calculator, go cos 30 times 15, and that gives us 12.99. We'll leave the decimals intact for now, we'll round off at the end. Okay, so 12.99. So we've got our two sides of that initial triangle. So let me write those in there. So we have 12.99 to the east, and then our vertical component was 7.5 to the north. Okay, so now what we want to do is basically repeat the exact same thing using the second triangle. So our second triangle, we're going to have a vertical component that goes up first, and then our horizontal goes to the left. Okay, so we want to basically do the exact same thing. Okay, so we want to find the horizontal and vertical components. In this case, the horizontal is our opposite side. So we'd have sine 20. Okay, so we got the opposite side, so sine 20 would equal x over 10, and then the same thing for the vertical component, but it'll be cosine because it's our adjacent, so cos 20 equals y over 10. So that's our calculations we need for the second triangle. So let's solve for each of those. So let's do the sine 20 first, so sine 20 times 10 gives us 3.42. And then do cos 20 times 10 gives us 9.40 if we round it off. Okay, so let's write those on our original triangle again. So we have 3.42 3.42 on the top and 9.40 on the side. And that's it. So we've got our triangles calculated. So we figured out all the components for the two vectors. So now when you look at it, you can see basically what we do have is we have two vectors that go up, right? We have our two vertical vectors. So if we can combine those two into one, so let's just make one tall vector that goes up, and it'll be 9.40 plus 7.5 because they're both going upwards, so we can add them together. So that would be the same thing as 16.9. And then if you look at the horizontal vectors, we got 12.99 to the right, but then we have 3.42 going to the left. So because those are in opposite directions, we need to subtract them. So 12.99 minus 3.42 gives us an answer of 9.57 to the right. That's the bigger direction. Okay, so what we want to do then, let's just put the two vectors head to tail. It doesn't matter whether I drew it like this or I could draw the 9.57 starting up here and go this way. It really doesn't make any difference. I just picked the bottom because that's going to look similar to our original, right? So now the question is, what is the resultant? So we want to find out what that side and angle is. Okay, so when you look at these two triangles, you can see that our original resultant right there should be the exact same as the green resultant that we're going to solve for now. Okay, so all we have to do for the green one is, just like we did with the other questions, find that length and that angle, and we're done. So the length is pretty easy. We just use Pythagorean theorem. So 16.9 squared plus 9.57 squared, and square root that answer. That gives us 19.42, or we'll just round it off to 19.4. And then to find the angle, we want to go opposite over adjacent to give us our tan, so that'll be 16.9 divided by 9.57. So on your calculator, when you do that, you go to 16.9 divided by 9.57, second tan that, and we get an angle of 60 degrees. So that's it. We've done the question. So the final step then would be just to state your answer. So we'll just state our answer in final vector notation, and let's round it off to 2 digits. Everything should be in 2 digits. So our final answer was 19 meters, right? The 19.4, we'll round it to 2, and our direction was 60 degrees. So we went east, 60 degrees north, and that's it. Okay, so you can see with this question we sort of did 2 steps. First step was break the original vectors into its 2 components, then combine those into one new triangle, and then solve that new triangle for the hypotenuse and the angle. Let's try one more, and that'll be it for today. So let's suppose in this case I've got a vector that goes 25 meters per second at an angle of, let's suppose that angle is 40 degrees from north to east, or north to west. And then let's suppose our second vector then goes down at, let's say it's 30 meters per second, and that one is straight south. Okay, so this one is perfectly south, the other one was at an angle of 40 degrees. So we want to do the exact same thing again. So let's break it into our horizontal and vertical components. So that first vector, we'll just do those two.